Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics on the forum, and everybody else just calls me Damon. My brother's TV died on him. He said they were watching it and had a loud pop and then it just went dead. And it's a Sanyo, which is also made by Funai Corp. It's a FW43D25F. Has power supply board BA4DV2F0102. And so they took it apart because they were like, they of course Googled it, him and my dad, and said, it said check the fuse. And so they didn't see a fuse because they were looking for a regular fuse and didn't realize that this right here is the fuse. It's F602. So they had taken the back off and everything already, so I was able to just take the 4 screws out and pull this out. So I've got my multimeter on continuity, so we can flip it over and check this fuse. And it even shows a little fuse symbol on the board, and we got nothing. First thing I checked was the legs on this FET, power supply FET, and it's dead short. And so I knew, uh-oh, we got a problem. So it's at least blown the FET. The other things we need to check, so the power comes in right here. It's a power plug, if I can get it out without making a mess. It's power cord, goes to that. So we will use that once we think we've got it fixed. Power goes out to the LEDs. Oh, let me get this in shot. Up here at these little connectors, and then this ribbon cable goes over to the main board that has the tuner and all the HDMIs and stuff in it. So power comes in here, goes through the fuse. There is a, looks like a discharge capacitor for this capacitor here, but we got filter capacitor and filter inductors, so it goes through those to the rectifiers. So we need to check the rectifiers. We're going to check them all with the positive there, and we should get a diode drop as long as we're putting the positive on the banded end. Then when we go the other way, oh, we should get that both ways because my dog's playing with her bottle. Every time I go to record, somebody's got to make noise because this is making a bridge rectifier. So it will check diode in both directions. You may have a power supply board for your TV. It may have an actual bridge rectifier module, but we're going to go up here and check these, and it's just charging the caps. That's good. These may be a bridge rectifier also. We'll have to look on the bottom of the board. The beep's gonna go away. That's good. Just charging the cap up the other way. And then we got these. Uh-oh. It's not supposed to beep in that direction at all. Yeah, we're in that direction. See how it stays beeping? So we got a blown FET, and we got 2 blown rectifiers. And I would say that based on this is going to be, it's going to rectify this, bring this up to, it's a 120 volt input, so these are 200 volt caps. That's the other thing we need to check. Just make sure if there's no voltage on these capacitors. There is not. 0.1, 0.2, something like that. That's good. We got a 2.2 and a silver, which I think that means a point, and then a gold, so I think that's going to be a 2.2 ohm. Let's see if we can measure that. 0.3. That might mean it's going to be a 0.22. I'll have to look up the silver. I don't have it memorized. Oh, well, you know what? I might be able to bring out the old Radio Shack thing here. So, resistor colors. What's silver? This one is silver. Divide by 100. So it is 0.22. Dog's crunching on her chew toy bottle. So 0.3, that's good enough. So we got a short here, This looks like it makes the low power for the motherboard, which concerns me. I have looked at the tops of all the caps, and they're all nice and flat still. These are inductors, they're coils, resistors, diodes. Got some diodes here we can check. That reads good. That's going to be okay, depending on what it's hooked in. It doesn't read anything backwards, which is right. We got, oh, and we're in resistance mode anyway. So this is maybe a 1.2. I can't tell what color that is. Looks like brown red, so that'd be 1.2. That all looks good. But this is probably building the power supply out here for the running the LEDs, and this is building the power supply going to the board. That's a little scary, because if something on the board caused this all to pop, that's bad. I'm hoping that this is repairable and that all this work and effort doesn't end up being a bad motherboard on there. But we have a ton of components on the back side. And anytime you're trying to troubleshoot this stuff, you need to look for the stuff like that you can measure easily. And let me get my glasses. So going for diodes, anything with a D on the circuit board here. So see how it says D606A. So we're going to try to measure all the diodes, and then you can measure caps for shorts like that. So we need it in diode mode. That's good. Shouldn't have anything in the other direction. This is a diode. That's not good. This looks like it's labeled D608A. That one's also shorted. We got a diode here. Got a diode here. Diode there. Diode there. Diode there. That's a resistor. That's a diode. I may have just measured that. We got a little transistor, it looks like, because it's labeled Q521. It's not supposed to have a short across there, and it's not supposed to have a short across there. So we've already got some control stuff blown. We got this one good. Yeah. So we've got this diode, wasn't it? Yep. And this diode, this transistor, that transistor, the FET that's here, these two diodes, and we've got quite a bit already popped. So all this is going out this way, so it's probably going to be this FET here is the output. That seems okay. That seems okay. Just charging up the cap. That seems okay. Trying to see, this should be ground, so I'm going to put a probe on there, and I'm going to go across these chips. I should only see one, maybe two grounded pins. That's good. Same pin from the last one, so they're probably the same IC. And no other shorts there. I'm happy with that. I can see there's some ground stuff there. Let's make sure we're ground to ground. Yeah, okay. So what we need to do, we need to check this MOV across here. Okay. And then we got purple, red, green. Let's use our little thing. You can print off a chart. Is that purple? Purple, yes. So purple, red, green. So 72, so it should be 7 mega ohms. So yeah, it's just a discharge resistor. 7.2 mega ohms. Should read out a range here. 7.2, that doesn't seem right. Have to double check and make sure. Oh, that's not purple. That's brown, red, green. So 1.2 mega ohms plus whatever else is. You got to remember, it looks like it's in parallel with this. We can determine that. Put it back on continuity. Yeah, so it's going to read off from what that is. I'll have to get it on this, since it's in parallel with this MOV, which is to help with surges and spikes. You would have to unsolder one leg to read this good, but the fact that the MOV is reading and stuff, I can live with that. I think that's going to be all right. This is a safety cap, it looks like. Yep. And so it's going from mains to the ground. And it should be like a class Y or X. Cap, I can't see the writing on it good enough. But it needs to be a safety capacitor. That's going to be the same thing here. This is going to be another safety capacitor going between. See how they got this little line drawn on the board? That's the hot. This is the high voltage side, low voltage side, and so you have to have safety caps going between it and ground and stuff. That's pretty standard for power supplies. So I did look this up, and I looked up a couple of the parts and stuff, and as I was poking around on the internet, I came across some eBay listings like this for the power supply. So right there it is. For 15 bucks, you can get a kit that comes with all this stuff. And look, it happens to have the 2 diodes, the 2 transistors. It does have a weird MOSFET there. That's not my style MOSFET, but it comes with that big resistor, the fuse, and all those diodes. And I happened to notice it was from Computech USA, and it was in Springfield, Missouri, which is I'm right outside of. So I was like, hey, that's pretty cool. I'd rather buy from somebody local. And so if I can get back over here to my stuff, there we go. So I swung by there and picked up a kit. And so here it is, and that it did have the correct transistor, but it does have those diodes and stuff, so it seems like that's pretty common. Apparently this resistor right here is possible for it to burn up and stuff, so looks like we should be able to replace those, replace that, and replace the little surface mount transistors and diodes, along with the fuse right there. So that's pretty handy. The other nice thing about whenever you stumble across a kit like this to repair your power supply that somebody's already got, that makes you know what you need to check. Now I'm going to go through, these are startup resistors, it looks like, to get that FET going. But I'm going to go through and check a few more resistors off camera and stuff. And but first thing I think I'm going to do is fire up the desolder stuff. You guys will probably get music, or you might just get funny noises while I fast forward through some of this to get some of this out of here. So we need to get these out, that FET out, the fuse out. I'm going to go ahead and take this resistor out and get a good measurement out of the board, because since I've got another one, and actually that one looks a little beefier, so it might be better. A little better power dissipation. So pile of parts going. They did have thermal paste on the back, and the back is sealed, encapsulated, so you're not going to have to worry about a little insulator or nothing on there. All that come out, so that's pretty good. So I'm going to look here. I'm going to assume they're right. Well, I'm not going to assume anything. I'm going to see if I can see the markings on this through the package. Maybe get a little light. There we go. ALG for Q621, which is going to be one of these two. Let me see what this says. ALY, okay, so it's an AL, and then the other one's a BKD. Let's see if the other one is a BKD or a BK. ALG, sorry, I'm looking at the wrong one. I need to get to this one. Come on. Give me your secrets without having to cut everything open. BW, what did I say this one was? BKD, and that's Q602. So match up Q602. I am going to go ahead and open this. Trying to find my razor knife. All this mess somewhere. Or a pair of scissors. Oh, there's a pair. There, I've cut it open here. So Q602. Slide it out here so I can see it. Maybe a little better. We just want to verify stuff. This is showing up as an FAYP, so they may have substituted something on this. So I'm going to go with the fact that they probably substituted, or that part may be obsolete, and this may be its replacement. I'm going to look at diode 608, which is hopefully one of these two. Hang on. The two I got bad are 608 and 607. And that is what those are. 608 and 607. So let's get 608 out here, or 607. I don't care. 607 is the first one that comes out. And this one is marked BR 607. Marked BR. I like it when they match up. You know, substitutes are just fine. I do it all the time in power supplies and stuff with car stereo amps. You know, we put 3205s in just about anything that can run it. Just because they work so well. They're affordable if you buy them in big old quantities, and since we can put them in most everything, I buy big old quantities, 100 at a time, bare minimum. I know guys that buy them by way bigger than that. So this other one is a GD. So 608 is a GD, and that's what it says on there too. So I don't know. I could maybe fire up my microscope, but just trust me on it. It's a GD. So that looks good. If I can get this back in the bag, there we go. So these were what is it? Oh man, 655 and 653. 655 and 653. Shows 6 of them, so I'll bet those two and these four are all the same, and I'll bet these four were for the main bridge rectifier build down here. But I'm going to pull this. These out. It is SR3200. What came out? What came out was an SB3A0. So again, it looks like they may have substituted a part. I'll bet, because it looks like these are B3200 and these are SR3200. Is that an R instead of a B? Am I looking at that wrong? Nope, that's a B. So I bet they've had to substitute those parts. And then the one thing we want to check here is this says right on the board 250 volt 2.5 amp on the fuse. And so we want to make sure 2.5 amp 250 volt. That's wonderful. I don't know if I can get that to focus. Almost there, almost focused. Yeah, 2.5 out, 250 volts. So wonderful. All right, so I'm going to trust, and I'm going to take those two diodes and those two transistors out then. Oh, puppy dog's attacking her toy again. It's a rainy day, and so she's bored. She's not got to go run around. You might be able to hear the rain in the background, actually. I'm not sure with this new microphone setup, I've been getting lots better background noise reduction. But she is being noisy. Alright, we're going to just take our soldering iron. I can zoom in here a little. And see if I can't show you how I'm going to do this. I'm just going to go add a little solder on each side of this diode, a little leaded solder. Get it hot. Oh, I see something here. Look at this right here. Do you see on all these components, see that red right there on each side? That's glue. And so that means that they have been glued down, and that means you're going to struggle mightily if you're trying to just get it off with hot air. So I'm going to get some good leaded solder on all that. And then we're going to have to apply, sometimes you got to apply some torque to it. Sometimes you can do it with the hot air, and the hot air will break down the glue, but not always. Kind of give it a push back and forth as I'm going back and forth. We're trying to crack that glue. We don't want to bubble up the board either. I wouldn't trust too much hot air on this board because it's probably, yeah, pretty thin and chintzy. So sometimes if your tip's wide enough, you can get on both sides and get that solder flowing on both at the same time. You can give it a little push, and you can break that glue free, and then you can get that sucker off there. Alright, we got that one off. This one's going to be more difficult because it's a little bit bigger than the tip of my iron, so I'm just going to go back and forth on it. Give it a little push, there it came off, and we flicked it out of there. did not pay attention which way those diodes went. Now, look and see if it's marked on the board. I hope it is. It looked like they were both going up, but I can't be for certain. Let's see if it's marked on the board here. Let's get a little bit of desoldering braid so we can see. Oh, I need to trim that off. It looks like they got that cleaned up. And get a little bit of IPA, isopropyl alcohol. In here. Let's clean that area up. I can't determine which way that's supposed to be going. So that it's got a glue glub still there in the middle. Alright. May have to do a little research, figure out which way. I think they were both up, but I'm not 100% certain on that. So let's go ahead and finish taking it apart. Should have paid a little better attention. I figured with all these diode symbols and everything, they'd have had it drawn on the board, but apparently not. That one broke away. And got that one broke away. Board. Sounds like the pupper needs to go out. She's not gonna like it because it is raining. But I will be right back and I'll do a little research and tell you what I find and how I found it on those two little diodes. I may go back in my video here, depending on how good of a shot I gave us, and look at them there. So I might be able to tell by the writing on them. All right, be right back. Okay, I did a little looking at the video. I couldn't tell very well in it, but I did happen to do a little searching for a schematic. I came up with this. This is for a Philips BA4DV2F power supply. Not exactly the same. It's only got one control chip here, where we have two on ours on the output, and it's only got a single LED. But I'm assuming that means that since we have dual LED outputs, they've just doubled this. This looks a lot like our ribbon connector. And then I zoomed in over here, because a lot of these companies build stuff for each other and everything. You know, I started matching up stuff to the board. So like we got F602 is a 2.5 amp fuse. Well, F602 is our 2.5 amp fuse. Our main switching FET here is a K7A60W. And if we go over here and we find our thing, here's a TK7P60W. So I think that's right. Here's two little switching transistors, if you can see my mouse swirling around them. That's the two things we had popped. They are a Q602 and a Q621. If you look back at our kit here, our FETs, or two transistors, sorry, are Q602, Q621. That MOSFET is Q600. That MOSFET is Q600. So everything's matching up. I kind of went over more and more of it, but then I came down here and found D608. It's a Zener diode. If it says open, which you see it say open right here, means it's not there, not used. But this is a 36 volt switching diode. And then I found the other Zener. Where did I find it? It was around here somewhere. Oh, right here. Sorry. Got D607, D601. Either one of those could be installed, but it looks like a 27 maybe, or a 2.7. I don't know, diode. Zener diode. Really stinking easy. See this little symbol right here on the bottom of these diodes? That's ground. So we know that the bar on the diode needs to go up. So both these Zeners are acting that way. So all I have to do is go back here to the overhead. All I need to do on this board, where those two diodes were, is find out which pad is ground. And that's really easy. We just put our meter. I don't know if you can hear all that rain out there, but it's coming down in continuity. And we get my glasses so I can see. And we're going to catch ground here. And that is the bottom pad on both of them. So my memory was right, that the line was up here the way I was reading it. So we're good. So we do know that the line on the diode is going to go up on, let's see if I can get you in the picture, up on this pad and up on this pad. So I can get to installing some of this stuff. I'm going to go ahead and put that big resistor in. Now I pulled the old one out, slightly different, but we're going to go ahead and make it tall like the other one, let it stand proud. They're probably doing that for heat dissipation. So I'm going to go ahead and stick it through and let it stand proud, and I'm going to bend it over here so that it stands up like that. That in. We can go ahead and snip these off on the fuse. While we're at it, we can stick the fuse in. Bend that out just a little bit. So we get zoomed in here. Oh, zoomed in a little bit. So this thing, you see this is where I've cleaned off with some isopropyl alcohol. This thing's got flux all over it. It's yellowy and stuff. It looks like it came out of a smoker's house, but I absolutely know that for certain it's not out of a smoker's house. So it's either flux residue, which is what it is, or bacon grease, one of the two. You know. We've replaced everything but the transistors and the diodes. Got a mess over here of stuff. So we're going to do a pair of diodes there and the transistors there. I'm going to clean that a little better. I think I'm going to play with the dog for a second, see if I can get her to take a little calm siesta so I can finish this recording without too much stuff. But see how dirty this is? I know that's just flux residue, it's all over the board. Like I said, I know for a fact this did not come out of a smoker's house, so clean up all my flux. Put those in, and we're going to clean up over here. And up here. I don't like leaving flux. It's made it sticky. I'll clean parts of it. Like I said, nasty. You can see it all along this bottom edge. You can see some of that residue there. Like I said, it looks like a smoker thing, but I know it's flux. Or bacon grease. Still could be bacon grease. You know, we are talking about my brother. So, alrighty. I'm going to get these two transistors one at a time, very careful, laid out here so that I don't screw this up. And I will try to be zoomed in enough and point it out and explain it. That way, if somebody needs to know exactly which one goes where, we can. Give me just a minute to get set up. Okay, I've switched to a smaller tip. We are going to start right here. Here's the transistor. This is D607. I'm going to put the tiniest little bit. See, I've switched to a smaller tip. Tiniest bit of solder down here. Just enough. That should be on the ground, and then I want to make sure I get diode 607 out. That's why I was real careful with the packaging to make sure that I didn't mix them up, because they are different voltage Zeners. Well, that's the only problem about getting these in the kit, is they've been snipped and they're hard to peel. There we go. Oh, pardon me. Alright. Oh, look at this. The base, the diode, it's got one little pad, one big pad. I don't know if I can see it here. So the line, this is the BR. The line is on this side. You flip this thing exactly over. If I can get it to flip exactly over. Doesn't want to flip in my hand. Come on. Now I gotta make sure we're gonna do it right again. Okay. Line's on this side. See if we can get it to flip in my hand. Notice how that's the big pad area. Big pad right there. That's hilarious. We could have figured it out that way. Set that in there, just like so. Make sure my soldering iron's clean and put a tiniest drop of solder on there. Get my multimeter out of my way so I can get a hold of this. Slide it over. melt that solder. Can I get a little pressure on the top? My doggo is still trying to play over there. And then we can do this other side. Come back over here with a little fresh solder. And Shazam. So I'm going to put a little dab on here, right there. And we're going to get diode D608 out. So 608 goes right here. I'm going to inspect this diode and see if it happens to have that same setup. The pad doesn't necessarily look that way, but we still got a bit of glue glob in the middle. This one's labeled GD, the replacement is, and no, the bottom is not. So we got to make sure when I put this down here that I get the lines going that way, going towards the top. There we go. Let's get in here and tiny drop of solder on my soldering iron. Kind of got it held in place there. I need to get my tweezers. And you could probably do this with hot air. I'm always worried about using hot air on cheap boards. They like to popcorn. It's got that. So let's go ahead and mosey over here. And we're going to put a little dab of solder up on this top pad for Q. I'm going to have to pick it up to look at it. Got a holder in my eyeglass. That makes it hard to see through. That bottom one is Q602. So we're going to get transistor 602 out of the little kit. I'm going to hope this all works. Like I said, I'm a little nervous that it popped those diodes on that low voltage side. Those are pretty beefy diodes to pop. So we will see if this works and then if the motherboard survived. Alright. So these on the orientation, it's pretty simple to see how they go. I'm just going to get a hold of it. Come in here. We're kind of down on the bottom of the view here. Just going to get that solder and just leave it there for a second. Now we can liquefy it. Pump this around. Put a little pressure. Let go. Let it cool, and then we can come in and do each leg. The reason why you clean the pads with the desolder wick and stuff is so that you can put plenty of fresh solder and there's flux in your solder, and that'll make sure you get a good joint. So now we have Q621. So I'm going to pull that out of the kit. That's everything we're going to use out of the kit. We didn't blow every diode, so the kit comes with all of them. That'd make me really nervous. Should have blown that bad, but get that over into place. Going to put a touch of solder here. I like these when they do the big long pad because that means I can actually touch at the top of the pad to get the solder melted. Float in once we kind of got it there. I'll put a little pressure on top to make sure the transistor's legs are setting on board. There we go. We get both those nice and shiny. We come back and we hit this once they're set up, and looks like we're good. Alright. Moment of truth. I'm going to plug in the power adapter here. I'm rolling back ways from it a bit, and I'm going to plug it in. Hey, I heard it go wing, but I didn't hear anything go kapow. So let's go to volts DC 200. And let's measure. We're going to measure up here on the you ain't gonna have anything because it's not being told to turn on. Duh. So on volts DC 200, go across these caps. You can see we're at 165 volts a pop. That's why I told you be careful. So at some point over here, we should be making probably 3.3 or 5 volts. So I'm going to carefully flip this over. And on the back of this connector, I see part of it labeled ground for a few pins there. And then maybe standby the 3.3. Not sure what pin would be what, but we're just gonna go pin to pin. There's negative 7.9. Negative 16. Negative 8. Negative 8. Negative 8.3. There we go. There's a 4.1. There's a 4. 4, so that might be close to the 3.3 and or 5. Nothing's blowing up. We definitely got voltage. Unplug it. Put the meter back on 200 volts and see how long it takes this to go down. Yeah, see, it's going to take a little bit for it to go down. It's dropping because I got my meter on there. If I take it off, we are at 122. It's going to set. So remember, if you take a good power supply out, and this one does not look like it's got any dropping resistors. It might have had some. Oh, yeah, it does. So it's at 75. So good design. Thumbs up on this. They got some dropping resistors to help make sure that there is not a charge that stays on that. I've got it unplugged, so as soon as that gets dead, I will put it back in. It's almost there. Oh, you can't see that. I will put it back in the TV and test it. And I'll use my phone to get a little footage of it working there. Hopefully working. I don't want to jinx us, but we'll see what happens. All right. Really quick, the TV did come with a couple different kinds of screws. There were a whole bunch of the silver screws are what holds the power supply board on. There are these machine screws, and there's these coarse screws. These go into plastic only, so there's holes that are only plastic. These other ones are the ones that thread into the metal. There's metal around the frame edge, just in case when you took them out you didn't know what went where. I have one of these in it right now and two of these in it, so 2, 4, 6, 8, 7, sorry 9. Looks like maybe 9 of them, and then I think I got one of these in it, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of those maybe. I think they've also got a couple of the screws for the base plate they stuck back in. It was my dad and my brother that took it apart the first time. So anyway, just in case you needed to know what those screws did, just look for the holes that have metal for this fine thread to screw into. Okay, here we are sticking the power supply back in. You'll see up at top here the connectors here for the LEDs. Sorry, this one's dual, and then this ribbon cable goes back into that slot. That had 5 of those silver screws to hold it in. I did miscount on the sheet metal style screws, the fine pitch that go into the metal, like over here. I did have 2 holding the cover on, 1 in each corner, so add 1 to whatever that total was. But then the only other places where there's something weird is there's a really deep hole that drops down in, and this is one of the machine screws, and then over by the by the HDMI ports and stuff is one that is a plastic screw, just in case you're trying to figure out where those are going. And so I got it stuck in, put all the screws back in, put it all together, and kablammy, it worked. Sanyo is working. So I texted my brother, and he was like, sweet, and he was like, I'll come by and pick it up tomorrow. So he got a working TV again for, what was that kit, 16 bucks maybe, plus some shipping, a couple bucks shipping or something like that. So $20 to fix this thing. Not bad at all, not bad at all. Better than probably what, I mean, this is a 1080p. Sanyo's not the worst brand and not the best brand maybe. So probably a $200 to $300 television. I don't know. It's like a 43 inch, I think it is. So 42 maybe, 43. So anyway, better than it ending up in the recycling, or in the worse yet, in the landfill. So it's a lot cheaper than having to go out and buy a new television. So hope you enjoyed the video. Give me a thumbs up, a like, a comment, or whatever. I appreciate all that, and I'll see you guys on the next fix project. Thanks, and I'm out.